This video is on systems of linear inequalities. Linear inequalities is an inequality in two variables whose graph is a region of the coordinate plane that is bounded by a line. Each point in the region is a solution of the inequality. So inequalities will have shading because inequalities could have multiple answers instead of just one, like linear equations. Equations will have one coordinate as their solution, but linear inequalities will have multiple coordinates as their solution. So just to see identifying solutions of a linear inequality, we're going to check to see, is the ordered pair a solution of y is greater than x minus 3? Because multiple coordinates could be a solution, we're going to check both of these coordinates to see if they are a solution. So we have an x and a y coordinate, and what we do is we substitute these values in for the variables. So the first one is the y. The y is 2. It's greater than, because we're asking that question, I'm going to put a question mark above it. We want to know, is it greater than? Then the x variable is 1, and then we're subtracting 3. So the question is 2 greater than 1 minus 3 is negative 2. Is 2 greater than negative 2? That is true, so yes, this is a solution of that linear inequality. The second example is negative 3, negative 7. So again, we have an x and a y. We're plugging into the exact same linear inequality. So the y value is negative 7. And we want to know, is this greater than the x value of negative 3 minus 3? So is negative 7 greater than negative 6? Negative 7 is actually smaller than negative 6 because when you go into the negatives, the larger the number, the smaller it is in the negative. So this is not a solution, so this is no. So when we're graphing them, this is just going to show what they will look like. So graphing an inequality in two variables. We're going to be graphing the line of y equals x, basically, but we're going to be looking at less than, greater than, less than or equal to, and greater than or equal to. So we're going to look at the different lines and shape type. So if we're looking at less than, so if we say instead of y equals, we're going to say y is less than x. We have to understand if we are going to be having a dotted line or a solid line, and if we're going to be shading above the line or below the line. So for this one, since this does not have a solid line with it, it is not an equal to, this would be a dotted line because it will not include the coordinates on the line y equals x. So if I draw the dotted line through for the line of y equals x, so the dotted line of this is going to be a rough sketch. Then I have to shade all of the coordinates or the region that would be less than this value. Now you could find coordinates on either the above part or the bottom part. So what I generally do is I put my, whatever I'm using, pencil, pen, on the line itself that I just drew, anywhere on that line. And it says less than. Less than is below a value instead of above. So if I'm going to go less than, I need to go below this line. So I'm just going to draw a line straight down. This tells me I'm drawing in this section of the graph. So the above section of the graph, everywhere above it, I'm going to ignore. It's everything below this section of the line and everywhere, the entire line. This is the part that I would shade. Now, on your calculator, there is a symbol that you can use. It looks like a right triangle, but the right angle is going to be on the bottom left because this is saying I want to shade down. It's almost like it's pointing an arrow downwards. So for the next one, the y is greater than. So instead of it being y equals x, it's going to say y is greater than x. So again, it will be that line y equals x, but it needs to be a dotted line. So just like this one, this was a dotted line. This one will be a dotted line. So again, I'm going to draw that same line that I did on that first example, a dotted line. And I'm going to put my pen on the line, anywhere on the line that I can easily see. And it says greater than. Now, greater than means above in value. So I'm going to shade above. So I'm going to go up. I drew a line straight up. That tells us, or tells me that I'm going to shade in this area, all the way along the line. All the way along the line. This is the shaded region. So any coordinate inside of this shaded region would be a solution to this. And again, on the calculator, there is a symbol that you can use. Again, it looks like a right triangle, but it is pointed in the other direction. It is pointing towards the top right. This one's pointing to the bottom left. This one's pointing to the top right. Now, less than or equal to. This one would be a y is less than or equal to x. So the equal to has that symbol on the bottom. All right. Y is, I will do that in blue. Y is less than or equal to x. This is a solid line. Because it has a solid part to the inequality, this will be solid. So in this case, the line would be just like if I were to graph y equals x. Just the basic y equals x. The only difference is now I have to still shade. It is a less than, and just like over here, the less than is shaded below. So I would put my pen on my line and shade below, because less than means under. So this is the section of my graph that I would shade. The symbol for the calculator, again, is still that less than, because I cannot do both the solid aspect or the dotted aspect and the shading aspect. So I just want to, if I use my calculator for this, I would want to know the shading aspect. So again, it's pointing to that bottom left in the calculator. And I will show that in the calculator. So again, that greater than or equal to, so that would be that y is greater than or equal to x. This is, again, going to be a solid line because there is a solid aspect to the inequality. So it will be a solid line of y equals x. And now I just need to shade it. So it says greater than. So again, on my line, I'm going to draw a line straight up. And this tells me the section of the graph I need to shade. And again, the calculator symbol will be that pointing to the top right triangle. And just to show you what this will look like in the calculator, I just want to go to my, I'll go to my y equals. I'm just going to type in x. Now, this would be a y is equal to x, so if I were to graph that, I would have this line. I cannot distinguish between the dotted line and solid line if I'm also going to be doing the shaded. So generally, dotted versus solid is easier to determine than the shading is. So if I want to go to the shading aspect, I'm going to go back to my y equals. And on the equation that I have, I'm going to go all the way to the left-hand side and have this blinking aspect here. Now, some calculators will have it different, but you're going to be looking for the same thing. I'm going to press enter on this blinking part where it's the line, and it will go to a very thick line. I don't want to focus on that. I'm going to press enter again, and then I have the shading aspect. This one is going to the top right, so that would be a greater than. So I'm going to graph this one to see what happens and make sure it graphs the same way. So if I'm going to press graph, I have the exact same shading, but this would be more of a greater than or equal to, because it's also the solid line. I would just have to make sure my line is dotted if it's a less than or equal, if it is just a greater than. So if I go back to my y equals, I'm going to go back to that side over there where the triangle is. I'm going to press enter again, and it turns into the bottom left. So this one should be that less than. So if I press graph, it will shade the same way that I have it on my paper. So these are the ways to graph the shading in your calculator. And you can always go back to the way the lines were by just pressing enter. If you have a much newer calculator or the color calculator, you can actually change the colors of your shading. You can change the lines as well, just like this, but you don't press enter as much, you just press left and right. So if I press enter again, this gives me something that we don't need to look at. Then it gives me, again, something we don't need to look at. Then it will give me the dotted line. So I could actually look at the dotted line, but it will not also show me the shading. If I do this, this will give me the dotted line instead of the solid. Go back to the y equals. If I press enter again, it'll take me back to the original. And this is the original with no shading. So again, in the calculator, it's that part right beside the y equals.